In this video, we're going to walk through a practice problem about sodium azide. And if you haven't already been able to try it out on your own, pause the video and give it a shot, and then watch the solution. So what we're looking at is a reaction between sodium azide, it's a solid that decomposes into sodium and into nitrogen gas. And so is decomposition reaction, we're going to try to predict the volume of the nitrogen gas that is made if we have 150 grams of the sodium azide that we start with. We have a little information. We know it's 1 atmosphere and 25 degrees Celsius. And so looking at this problem in general, we're going to go from, hold on, we're trying to take information about the sodium azide that we know, which is 150.0 grams. And I went ahead and calculated the molar mass for it already. It is 65.0099 grams per mole. And we're going to try to figure out how much of this nitrogen is produced. And so we want to know the volume. So that means we're going to need to use our ideal gas law to solve for that. Now, we don't know moles. That's the information we're going to get from the stoichiometry piece of this problem. But we do know R. We do have our temperatures 25 degrees Celsius, which converted to Kelvin is 298 Kelvin. And we know our pressure is 1.00 atmospheres. So really, once we have the moles of our nitrogen, we'll be able to easily solve this with the ideal gas law. So I think that the hardest part of these problems, since these are calculations we've been familiar with, is really setting up the strategy itself, because the problem doesn't feel like it gives you a lot of information. Although we have a lot more just hidden and embedded in this chemical formula. We have a ratio, a mole ratio between our reactants and products, and we have molecular masses associated with each of these chemicals. All right. So let's get started. We're going to start with that 150.0 grams of our sodium azide and convert this into moles using our molar mass. So times 1 mole and 65.0099 grams per mole. These are going to cancel out. I'm going to get units of moles. And I'm going to keep going because now I know I have moles of sodium azide, but I don't actually want that. I want moles of nitrogen gas. So I'm going to do a mole to mole conversion as the second in the stoichiometry problem steps. And so I know that from my coefficients that every 2 moles of sodium azide that reacts will produce 3 moles of nitrogen. So I'll have 3 moles of nitrogen on top because that's the units I'm interested in. And I really want to cancel out these moles of sodium azide. So that has a coefficient of 2 right there. And now I'm going to end up with the number of moles of the nitrogen that's produced. And that I'll be able to put into my equation right here using the ideal gas law to calculate calculate volume. So plugging this into my calculator, what I get is 3.461 moles of nitrogen. All right, cool. So let's go ahead and figure out what the volume of all of this nitrogen that's produced will be. So I'll plug that number of moles that I just calculated and multiply this by my ideal or my gas constant. And I'm going to use the one that has atmospheres for units because my pressure was given to me as 1 atmosphere. So the volume that this nitrogen will occupy will be 84.7 liters.